274. I am going to color code f of x in blue and g of x in green. And it asks us for the domain and range of them, so I'm going to just draw a quick sketch of the graphs because they're graphs that you already know. X plus 2 would have a y-intercept of 2 and a positive slope. It would look like this. And absolute value of x is this V-shaped graph. So domain and range for both of them, well, domain is everything, range, everything, and for the green one, domain is everything, and the range is bigger than or equal to 0. All right, no problem there. And then h of x is going to be f of x plus g of x. And we have some new notation or new terminology here. They ask us to write the explicit equation. And this is the wonderful thing about math, is if you don't know what the words mean, you're in trouble, because you'll have no idea what to do next. So we have to know, well, what does explicit equation mean? This, which they gave us, most likely isn't explicit equation, because it's very rare in a math question where they say, do something that we already did for you, but we're just not telling you. This isn't an explicit equation because it's in terms of f and g. An explicit equation is in terms of just x. So all we would have to do to get our explicit equation is instead of writing f of x, write x plus 2. And instead of writing g of x, write the absolute value of x. So I just substituted those in. I guess we wouldn't need any of those brackets, actually. Now, unfortunately, we've never graphed something like this before with an equation and an absolute value built into that equation. So we have a couple of options. We could add our graphs together, which we did before. That wouldn't be bad, that wouldn't be hard. All you do is add the y values. If you have an explicit equation, you could also just get a table of values and see what happens. Like, what happens when I plug in 0? Well, my h of x, I guess I could write actually h of x here. If I plug in 0, I would get 2. If I plug in 1, I would get 4. If I plug in 2, I would get 6. And we can get a sense of what's happening to this graph. 0 and 2, 1 and 4, 2 and 6. We've got those 3 points. And that probably makes sense that if you added this straight line to this straight line, you would end up with this straight line. Question?
Yeah, but then are we going to have to start going into some x's that are negative?
X's that are negative, so let's see what happens when we do that. Just going to... So what would happen if you plug in -1? This would be -1 plus 2, and then this -1 would become a positive 1. And you just get 2. And if I plug in -2, I get -2 plus 2, and then plus absolute value of -2 will be 2 again. What do you think is going to happen when you plug in -3? You get 2 again. And so based on the pattern, it sort of seems like this goes like, wow, it's not green. This goes like this, and this goes like this. It's kind of weird.
Just a question. The 2 brackets that are just lines, I haven't had that before. That just makes it positive, isn't it?
The 2, that just makes it positive, and that is this graph.
Yeah.
Okay. And I'm going to introduce to you, so we did the graph. just finish this question. From this graph, I hope you can see the domain is still everything. And the range is bigger than or equal to 2, which I think was not obvious from the equation. The range is not usually obvious from the equation. The domain can be obvious from the equation because the domain is asking, what are your x values that you're allowed? And in this case, I can put any number into an absolute value. There's no restrictions anywhere, so it makes sense that my domain is everything. But the range we had to find from our graph. Now, this graph was tricky because of its form. I'm going to introduce to you something called, and this you'll need for AP Calculus next year, piecewise notation. Sometimes you have a graph that looks like it's two different graphs pieced together or put together. Does the graph that we got look like two lines, one flat line, one different line put together? The most common or the very first piecewise graph that most people see is actually the absolute value. You can write it as the absolute value of x, but can you see that it's two pieces or two lines put together? So if we think about it, if I think about the absolute value of x, the absolute value of x is actually, right, here's the absolute value of x, I'm going to draw it in purple. It combines this line, but only a piece of it, and this line, but only a piece of it. So what we can do to write a piecewise function, it looks like this. The first piece is part of the green graph. What is the equation of this line that's the whole green line? It's y equals minus x. When do we have that piece for the purple graph? We have that piece only when x is less than or equal to 0. So we have the green graph only when the x values are negative. And then we have the blue graph, which is x, only when the x values are positive. Check it out. If you plug in -2 into this equation, what are you supposed to get? You're supposed to get 2, right? If you plug in -2 into this equation, you have to decide, which one do I plug it into? Well, because -2 fits in this domain, we plug it into here. What is -2? +2 as well. Do you see how the two are the same, but just written in different ways?
Why is it greater than but not equal?
When you write an equation, you're supposed to have it equal only in one part. It wouldn't matter where I put that equal sign. But it could be problematic if, in this graph, they touch at exactly the same point. So technically, had I put the equal sign here, it wouldn't really cause a problem. But sometimes it causes a problem with no longer being a function if it's included at two different points. So generally, when we have a piecewise function, we include the value with one of the graphs, but not the other one.
Can you just choose whichever one you want?
You could choose whichever one you want, especially if they're joined at that point. Sometimes you have a piecewise graph that looks like this. Then this point is filled in, you'd have to include it in that graph. This point is not filled in, so you can't include it in that graph. Okay, so we are now going to look at h of x, which was x plus 2 plus the absolute value of x, and look at what happens when we change h of x to a piecewise function. Well, if x was less than or equal to 0, then the absolute value is actually -x. And if the x is bigger than 0, then the absolute value is just x. simplifying this, gives us just 2. Did we not just see on our final graph that we had just a flat straight line at 2? When x was less than or equal to 0? And then we got another line with a y-intercept of 2 and the slope of 2 when x was bigger than 0. We zoom out here and look at our graph. Wow, that's not our graph. When x was less than 0 on our green graph, it was just equal to 2. And when x is bigger than or equal to 0, it's 2x plus 2, which is that line. So a piecewise graph can sometimes help us draw it faster than a table of values, can also help us draw it more accurate, and can help us with the domain and the range. So we're going to use that for part C. So part C says now we're going to multiply. So for C, P of x is going to equal f of x times g of x. That's the explicit equation. If we want to write this explicit equation in piecewise notation, absolute value of x is negative x when x is less than or equal to 0, and absolute value of x is positive x when x is bigger than 0. Which means, if I multiply that out, negative x squared minus 2x for x less than or equal to 0, and x squared plus 2x when x is bigger than 0. Now I'm going to graph this piece in blue and this piece in green. And I'm going to graph the whole thing first with the dotted line, and then we'll see what the end graph is going to look like when we're all done. So, for the blue one, this reviews a little bit of chapter 1. It also reviews a little bit of grade 11, graphing parabolas. If I was graphing the blue one, I would see that it's a parabola, and I'd see that it opens down. I would see that I have the factored form, so I would know that I have an x-intercept at 0 and at negative 2. Since it opens down, my vertex has to be at negative 1. I could either plug in negative 1 to get 1, or I could use the fact that the a value is 1, that I would have to go over 1 down 1, so it has to be there. I'm going to draw this with a dotted line. This is my parabola with a blue. Next, my green graph. Similarly, it's factored, so I know that these are my x-intercepts. It has a positive a value, so my parabola is going up, so I would know its vertex is there. And that is my green graph. Now, P of x is a combination of those two graphs, the two pieces put together. So I take out my purple pen, and I say, well, when am I going to take the blue graph? I'm taking the blue graph just when the x values are less than or equal to 0. So I include 0, and it's on the blue graph in this direction. See how that's the blue graph is just when the x values are less than or equal to 0. Then we take the green graph when the x values are greater than 0, so that part is the green graph. It looks very similar to an x cubed graph, except this point right here is extremely sharp. Be careful, if you touch it with your finger, it'll prick it, you'll bleed all over the place. Like, x cubed graphs are not dangerous, that's why they're in grade 12. This graph is a little bit more dangerous, you could hurt yourself with that very, very sharp point. I would argue this is a lot more accurate and actually easier to graph than the alternative of, right, how do you multiply? You take y values and keep multiplying until you get your final graph. Does that look like two parabolas put together? Not really. Okay? But this is the shape of our final graph. And then from here, does it ask us for domain and range? So the domain would be everything, and the range is everything. You will often find with graphing that if they give you the actual equations, writing the explicit equation and graphing that is often easier than just adding y values or adding or multiplying y values or whatever. You can often get things a lot quicker this way. Okay, questions for practice on this one?